Okay, this video looks at a particle moving in simple harmonic motion, and we're trying to find the distance moved, in this case for the particle moving with this equation, with x in metres and t in seconds. So what's actually happening here is that the particle's moving up and down the x-axis here. Got time on this axis. We know that first of all the amplitude of motion is equal to 2, or 2 metres in this case. In other words, the distance from the mean position, maximum displacement from your mean position is 2 metres. And then in terms of the period of motion, we use this k value here of pi on 3, and we say that the period, sometimes we use capital T to denote period, is equal to pi on 3 over, oops, got that the wrong way around. Let's get rid of that. It's actually 2 pi over pi on 3. Pi's cancel there. We're left with a period of motion there of, what's that, 2 times 3 is 6 seconds. So in other words, with our particle moving in simple harmonic motion, it looks something like this, following the sine curve. And the period of motion there is 6 seconds. So we've got 3 seconds over here. We can see that the maximum value here will be at 1.5 seconds, and so on, 4.5 seconds. Okay, so we want to find out the distance moved. Let's see if we can work it out for the first 2 seconds of motion. So find distance travelled in first 2 seconds. So what we can see that's happening here is that the particle starts off here at the origin, moves up to this point here, so that takes 1.5 seconds. It's going to move through that value to the amplitude of 2 metres. So it moves 2 metres in the first 1.5 seconds. Then it's going to sort of move down here somewhat, and at 2 seconds, which will be about here somewhere, it's going to have moved from the maximum displacement down to this value here. So all we've got to do is have a look at the different intervals through which it travels. So first of all, from t is equal to 0 to t is equal to 1.5, we've got our distance is equal to 2 metres. So that's pretty easy. Then we want to look at distance travelled from t is equal to 1.5 to t is equal to 2 seconds. So we just find the displacement at 2 seconds, x at 2, which will be equal to 2 sine pi on 3 times 2. In other words, we've got 2 sine 2 pi on 3, and we'll notice that that does give us one of our exact value quantities. So sine of 2 pi on 3. Let's have a look at that. Let's just check that out. We've got our unit circle here, got pi on 3, same as 60 degrees, around to 2 pi on 3 here. So sine of 2 pi on 3 will be the same as sine of pi on 3. So there's our angle in there. So we've got root 3 on 2. So our displacement at t seconds will be 2 times root 3 on 2. 2's cancel. We get root 3 metres. So what we can see here is that the particles moved between 1.5 and 2 seconds from a displacement of 2 metres. So on our graph it's moved from 2 metres down to root 3 metres. So in this time the distance, oops, let's move that up a little bit, distance will be equal to that 2 metres, take away the root 3, and then our total distance travelled is equal to our 2 metres in the first 1.5 seconds plus our 2 take root 3 in the next 0.5 seconds, which comes out to 4 take root 3 metres, or if you like as a decimal, we can work that out as a decimal as well. Let's see what we get here. 4 take comes out to about 2.27 metres for our answer. Now, the other thing to note here is that if we can use our class pad, this is a very easy question to do on our class pad. Distance is equal to the integral of the velocity dt between 0 and 2, and to allow for the fact that we've got some displacement and then moving backwards this way, we want to add it on, we've got to take the absolute value of the velocity function. So into our calculator, we would first need to work out what the velocity is. So our velocity would be dx dt. So we've got x is equal to 2 sine pi on 3t, then velocity is equal to 2 pi on 3 cos pi on 3t. And so our distance will be the integral between 0 and 2 of the absolute value of that expression for velocity. And obviously a bit quicker doing that than running through the by hand process over here. Oh, there you go. So there's the rule that you use there. Don't forget your absolute value signs, and that'll give us our distance, which should come out to the same value of 2.27 metres.